All right, we're back. Just thought I'd give you a break. All right, so in the last video, we learned the formula for finding an arithmetic sequence, how we find the rule. So the rule was an equals a1 plus n minus 1 times d, where a1 is standing for the first term and d is standing for the common difference. All right, so in the last video, I gave you a sequence and you wrote the rule, okay? In this video, we're going to write the rule given other things. So our first example here is finding the rule for an arithmetic sequence if I gave you just any term and the common difference. So basically that's all I need to know to be able to generate the entire sequence. So for example, if I gave you that I knew A19 was negative 45 and D was negative 3, I can go ahead and come up with a rule that is going to generate the entire sequence. All right, so how I'm going to do that is, what is the thing that I don't know? Here is I don't know the first term. So remember, in order to fill in this formula, the two things I need to fill in are the A1 and the D. So I need to be able to find that first term. I have the D. So I'm going to solve for A1. I have the N right here. This tells me that N equals 19. All right, so I'm going to fill in for A19. All right, so A19, I do not know what A1 is, but I know that N is 19 minus 1, and the common difference is negative 3. But I also know that A19 is what? Negative 45, so I can fill in that. And 19 minus 1 is 18. 18 times negative 3 is negative 54. So now I have an equation I can solve. Add 54 to both sides. I get A1 equals 9. All right, so now I can just fill in my formula. I get AN equals A1, which is 9, plus n minus 1 times negative 3. And again, we'll simplify that. And if we simplify that, we get 12 minus 3n. All right, so what did we do? We substituted into our formula to solve for A1. All right, let's do another example like this. You may want to pause the video and see if you can do the example, and then come back and see if you get the right answer. So we're gonna say, I know that A12 is 52 and D is 6. So again, I'm gonna plug in and solve for A1 because that is the missing information here. So A12 equals A1 plus 12 minus 1 times 6. Where did I get that 12? Because I know that this is n. All right, I can also substitute 52 in here. 12 minus 1 is 11. 11 times 6 is 66. So I am going to subtract 66 from both sides, and I get A1 equals negative 14. Go ahead and plugging that back into my formula. I get negative 14 plus n minus 1 times 6. I simplify that down. I get 6n minus 20, or negative 20 plus 6n. All right, let's change our givens and see if we can still write the formula. What if I just gave you any two terms? I didn't even tell you what the common difference is, but I did tell you that it's an arithmetic sequence. So that's the important thing. I tell you that it's an arithmetic sequence, and I tell you that I'm given any two terms. Can you figure out the formula. All right, so you've done this before, guessing and checking. So for example, if I told you that A7 equals 17 and A26 is 93. Then remember in elementary school, you'd write 17 and then you put a bunch of lines in between that wouldn't be so long to 93, and then you kind of work backwards to figure out how to get the rest of the numbers in between. Well, we don't want to do that with these big, with 26 places. So we're going to use our formula again. So remember, our formula is this. All right, there are two pieces of information we need this time. We don't know A1 and we don't know D. So if you remember, when you're solving an equation and you need to find two variables, you need to have a system of equations. So we're going to solve a system of equations to find A1 and D. So first I'm going to get one equation by plugging in A7, and then I'm going to get a second equation by plugging in A26. All right, so if I go ahead and plug in A7, I get A7 equals A1 plus n minus 1, 7 minus 1 here, I'm sorry. We don't know this or this, but we know A7 is 17. So I get 17 equals A1 plus 6D, okay? If I go ahead and plug in A26, get A1 plus 26 minus 1D. A26 is 93. I get 93 equals A1 plus 25D. So now I have two equations. We just simply need to use either substitution or elimination. I'm going to use substitution because it's easy to solve for A1 here. A1 equals 17 minus 6D. And then I can substitute that into the second equation. So 93 equals A1 now becomes 17 minus 6D plus 25D. I simplify that down, I get 17 plus 19D, subtract 17 from both sides, I get 76 equals 19, D, divide both sides by 19, D equals 4. All right, now what do I have to do next? I need to substitute to find A1. So here, A1 equals 17 minus 6 times 4, because D is 4. So I get A1 equals 17 minus 24, which is negative 7. All right, so now I can go ahead and fill in my formula. I'm going to skip back to the top just because I've run out of room here. So I know that D was 4 and A1 was negative 7. So I get negative 7 plus n minus 1 times 4. If I simplify that down, I'm going to get 4n minus 11. All right, last but not least is how do you find the sum of an arithmetic sequence? without having to list out all the terms and adding them all up. Okay? So finding the sum of an arithmetic series. See, I switched the word to series because now we're going to have the terms with plus signs in between them. All right, the formula for that is going to be S sub n equals A1 times n. That's wrong, sorry. N times A1 plus AN over 2. Okay? This tells me how many terms I'm adding. I can't add an infinite number of terms, right? So I could even write here the sum of a finite arithmetic series because I can't add an infinite number of terms. All right, so say I have the series and I have it written in summation notation, I equals 1 to 29 of 3i plus 7. And I want to find the sum of the first 29 terms. Well, what do I need in my formula? I need n, I need a1, and I need the first term. This stands for the first term. This stands for the last term. And this stands for the total number of terms. All right, so what we need to do is we need to find the first term, which is A1. So how do we do that? Plug 1 into here. First term would be 3 times 1 plus 7, or 10. Okay, find the last term. We would get that by plugging in 29. So 3 times 29 plus 7. And that comes out to be 94. Not 1,000. Or some of them come out to be 1,000. All right, and then our n in this case is going to be 29. All right, so if I fill in my formula here, so the sum of the first 29 terms equals the total number of terms, 29, times the first term plus the last term divided by 2. So I get 29 plus 104, times 104 divided by 2, and that comes out to be 1,500 something, 508. All right, so again, we wouldn't have wanted to have to write out all 29 terms and then put them in a spreadsheet or in a calculator and add them all up. I mean, you could have done that, but using the formula, it is much quicker. All right, I think it's worthwhile to do one more example of these before I let you go. All right. So there's our formula again. And the equation we're going to start with is I equals 1 to 18 of 6. We're going to use k's here. K equals 1 to 18, 6k minus 2. Again, we can use any variable here. So again, we need to find n in this case is 18. We need to find a1, and we need to know a18 in this case, a18, because that's the maximum. All right, so if I plug in 1 for k, I get 6 times 1 minus 2, or 4, so a1 is going to be 4. If I plug in 18, I get 6 times 18 minus 2. That's going to be 108 minus 2. Am I correct there? No, it's not that. I think it is that. I think my answers might be wrong. Let's do 18 times 6. 48, carry 4. 108 minus 2, good. 106. So to find the sum now, to use the sum formula, the sum of the first 18 terms is 18 times 4 plus 106 over 2. So I get 18 times 110 over 2, which comes out to be 990. All right. Any questions on that? If you do, send me a message, or we can FaceTime, or we could Google Hangout, let me know.